Sanbonani Abafundi, welcome back. So today we're gonna carry on with our study of inverses, and we're gonna dive straight in. And we're gonna look at a hyperbola. All right. So you may or may not remember these from grade 10 and 11. Quick reminder here, okay? If we strip out this movement, we're gonna get y equals 8 over x. All right. That's basically the basic function that we're dealing with. But what we know is that adding 2 to the x value moves the function 2 to the left. Okay, so we're going to look at that. But before we even do that, let's just multiply both sides by x here, just to help us understand something about this function y equals 8 over x. Okay, we want x values and y values that multiply together to give us a positive. Now, there are two possibilities. We could have x and y both being positive, or we could have x and y both being negative. Now, x and y are both positive in this quadrant. Okay, and the graph looks something like that. Or if we have them both negative, then we're in these two quadrants. Okay, later this term we're going to be doing some trigonometry, and we again will reinforce this idea of where x and y are positive in which different quadrants. Okay, right. As I said, what the plus 2 is going to do, it's going to move this graph 2 units to the left. Okay, now just to save a little bit of time, I'm going to see if I can just delete this axis. Yeah. If the graph moves 2 units to the left, the axis actually moves 2 units to the right. So the graph's going to look something like that. It's going to have an asymptote there, a vertical asymptote. So that's basically what our graph is going to look like. I think we can see that it is not going to have any x-intercepts, all right? But it will have a y-intercept. How would we find the y-intercept? Well, we'd find the y-intercept by letting x be 0. And so, in fact, the y-intercept of this graph is just 0, 8 over 2, 4. Okay, and we can now go and draw this graph, but let's remember that it does have a vertical asymptote at x equals 2. Okay, now 2 minus 2, x equals minus 2. So if we were drawing it, first thing we'd do is we'd draw in this asymptote over here, right? We know that this graph has a y-intercept of 4, right? And then we know that it's basically going to do kind of something like this. Okay, it's going to kind of go something like that. I'm not too fussed about exactly what it looks like. It's not a straight line, right? And then what it's going to do over here on this side, it's going to do kind of something like this. Okay, we could be a bit more fussy. We could plot a few more points for more accuracy. Let's just talk about the domain and the range of this function. Okay, firstly, it's 1-to-1. It's a 1-to-1 function. So we don't need to worry about restricting the domain. If we've got a 1-to-1 function and we swap that around, we can have a 1-to-1 inverse. So there are no domain restrictions there, but there is a restriction on the domain. Can this graph go everywhere? Actually not. It can go everywhere apart from 2. X is not allowed to equal 2. Okay, what about its range? Well, its range, it can go as far up and down as we like, but there's also an asymptote in here on the x-axis. The line y equals 0 is also an asymptote. So in fact, y not equal to 2. That's the domain and the range of that graph. Now we're going to try and find the inverse function. Okay, remember how we find an inverse function. We're going to write it as y equals 8 over x plus 2. We're going to swap x and y around. X is 8 over y plus 2. We're going to multiply both sides by y plus 2. Remember, I'm trying to get y on its own, so I'm actually not going to multiply that in. All right, I'm trying to get y on its own, so now I'm going to divide both sides by x. So I'm going to get y plus 2 is 8 over x. And lastly, I'm going to subtract 2 from both sides. You might remember from an earlier lesson, if we multiply this in here, right, then I mean, it's absolutely fine to do that. We'll get to the same place ultimately, okay? But there's our answer, okay? And this is in fact the inverse function. Now, this is also a hyperbola. This one has got a horizontal asymptote of -2 and a vertical asymptote of 0. So let's just have a look. It's got a vertical asymptote of 0 and a horizontal asymptote of -2. Okay, and in fact, what it's going to do, it's going to do something. Okay, we can work out. It's not going to have. This one is not going to have an x-intercept, a y-intercept, but it's going to have an x-intercept. Okay, it's going to have an x-intercept when y is 0, right? And if y is 0, then we've got 8 over 4. 8 over something must be 2. So, in fact, this point is going to be the x-intercept. That shouldn't surprise us because there's the point 0, 4. Swap that around. What do we get? 4, 0. All right. So this graph's going to do something like this. Okay, and I haven't drawn this very well, but it's going to come down like that. It's going to go through there, and it's going to go through there. And what we're hoping you can see is that this piece here is actually reflected over there, and that piece reflected over there. Then it is also going to go in here. So it's also going to go in here. Okay, and this piece over here, I'm just going to highlight it. This piece over here actually reflects to that piece over there. Okay, we're hoping you can see that reflection. That if you folded the page over, you'd get those bits of graph like that. Okay, the last thing we need to talk about is what is, and I know this whole thing's a little bit messy, which is why I've tried to use different colors to help us see what's happening. But what is the domain of the inverse of the domain of the inverse function? Okay, what is it going to be? It's going to be, what sorts of values can I put into the inverse function? I can put in anything. Sorry guys, I've messed this up. I've just realized here. This is not y not equal to 2. This is y not equal to 0. Okay, what about the domain of my green function? And if you go and look at the actual rule here, what can x not equal? X cannot be 0. And what about the range? And I'm sorry we left this out, range of the inverse. Well, it's y. Let's look where the I've just spotted another thing here. This was actually not x not equal to 2. It was x not equal to -2. And our range of our function, so of our inverse, if we look at it, it can go as far up and down as we like, but it never hits -2, not equal to -2. And just as we did last time, okay, we want to look at this. Notice that the domain, the things that we're allowed to put into our function, everything but 2, those are all the things that we can get out of our inverse. So the domain of the function, not equal to -2, is the range of the inverse. And the range, the range of the function, so let's have a look. The range of the function not equaling 0 is the domain of the inverse. This is always the case. And it makes sense because our inputs have become outputs and our outputs have become inputs. So the domain of the function becomes the range of the inverse. The range of the function becomes the domain of the inverse. That's quite a messy one to draw. Okay, now we're going to ask you to just try, we're going to ask you to pause the video, and we're going to ask you to try and draw. We've just given you a picture of some functions, and we're going to ask you to try and draw the inverse functions on the same axis. Okay, and remember, the most important thing is that we need to show a reflection each time. We need to show a reflection about this line y equals x. Okay, so pause the video, have a go. Remember, what's going to happen is that any point that's on here is going to swap around. So get the full name of some points and then swap them around. Pause the video and have a go, and then we will check just now. Okay, so 0, 2, 2, 0, 1, 3, 3, 1. Looks like 2, 5, 5, 2. I'm just kind of swapping them around. And then it seems to go towards an asymptote of like y equals 1. And that means on this side, it will go to like an asymptote of x equals 1. So if we draw that nicely, it looks something like that. This is the inverse of f. The most important thing we can see is that it is a reflection, mirror, isibuko. It reflects over the line y equals x. Okay, let's look at the next one. This graph, interestingly, is actually an exponential graph. And now you're probably thinking, well, what's this graph? We're going to get to that. Okay, let's look at another one. This one, 0, negative 1, negative 1, 0. Negative 1, negative 2, negative 2, negative 1. Looks like it goes through about negative 2, negative 5. Swap that round, negative 5, negative 2. And what we get here is we get almost like it's a piece of a parabola on its side. This is the function, and this is the inverse function. Okay, it's a reflection, mirror isibuko. Mirror isibuko. It reflects over the line y equals x. Okay, right, and the last one, let's see how we went with this one. Also a piece of a parabola, 0, negative 2, negative 2, 0. Negative 1, sorry, 1, negative 1, negative 1, 1. 1 comma something, 0, 0, 1 comma something. And we can see what's happening. We're actually going to get a graph that's going to do something like this. This point is 2, 2. Swap 2, 2 around, and you still get 2, 2. And so what we get is we get a sort of piece of parabola that looks something like that. Okay, this is the inverse function of x. Okay, and so what we'll see again is that it just kind of swaps over. It's reflecting over this mirror line. It's reflecting over this mirror line. Every time it's reflecting over this mirror line. Notice when it's on the mirror line, when one of them's on the mirror line, they're both on the mirror line. Does it make sense? I hope so. Right, it always makes sense. Okay, if you need to, pause and rewatch these. So just so you kind of fully understanding it. In the next lesson, we're going to introduce the sort of last piece in this topic, and that's on what we call logarithms. Okay, right, and it's a really cool piece that I think you're going to enjoy, and we look forward to seeing you next time. Now, this video has been a little bit shorter, maybe. If you are not at the end of a lesson, then start the next video. Okay, don't feel that the lessons have to match the videos have to match the lessons exactly. Sometimes you'll get through more than one video in the lesson. All right, keep working hard, Abafundi. Have a great day. Cheers.